Guys, one last lesson on probability, and that is lesson 11.4. We've done probability the last two lessons, yes? So this is really a continuation of the probability we've been doing. What we're talking about today, though, is conditional probability. So when we talk about conditional probability, the probability that an event B will occur given that another event A has already occurred is called conditional probability. Conditional probability, basically we're looking at the two events are dependent upon each other because you're pulling from just a pool of whatever the first event is. You're just pulling from that certain selected pool of people for your actual probability. So when we look at this, you will see some of these as we go through written with I want to say slash with them, but it's a straight vertical line. I honestly don't know the name of other than it's a line. There might be some official name for it, but I don't know what it is. So, but this probability of P/A is the probability of B given A. So the probability of B given that the first thing A is true. That is kind of what you'll hear me reading today and what we're going to be looking at. And so it basically comes down to our denominator will not always be all the possibilities. We'll have selected possibilities there. So let's look at example 1, and I'll try and make this make sense. The table shows students by gender at 2- and 4-year colleges and graduate schools in 2005. You pick a student at random. So they've got lots of data in the table, and they're going to give you this data in the table type situation. Notice it's broken in males and females. Officially, it says in thousands. So really, when we talk about this, males in thousands, like in 2-year colleges, this is 1,866,000. So this is really more like 1,866,000. But because they're all given in the same form, we can just use the numbers given. Okay? So we've got 2-year, 4-year, and then graduate schools, males versus females. Example A says, what is the probability of selecting a female given that she is in graduate school? I'm trying to think how to read that properly. What is the probability of selecting a female given that she's in graduate school? I'm trying to think if there's a better way to say that. What is the probability of selecting a female? Well, but there's a difference. If I just say what's the probability of selecting a female in graduate school, what are you going to do? You're going to take the females in graduate schools and put it over all the other students.
Yeah. Or you could just
okay, but we're not using all the other students. This situation was the probability of a female given that the student is a graduate student. That's more what I want to say, I guess.
That's how I took it.
Okay, and maybe that's how you took it. Maybe I'm overcomplicating it. But females is our person of choice here, given that the student is a student in graduate school. So when we set this up, on top, we're going to be looking at specifically which students?
Females.
Females that are what?
Graduates.
In graduate school. Out of, what are we going to be looking at on bottom? All the graduate students. Okay? This problem has nothing to do with the 2- and 4-year colleges. We are just looking at all graduate students. Okay? So that second part there is specific to what our denominator is going to be. So in this case, how many females in graduate school do we have?
19.
We're going to use 1,954. Technically it's in thousands, but that's all right. Over
3,000.
all students in graduate schools, which Okay, 3,303, which it's the 1349 plus the 1954, right?
Yes.
Which you guys told me as 3303.
You have to write that down.
You do not. Okay. My purpose for writing the 1349 plus 1954 is someone that goes back and looks at my notes later. Well, that maybe help them understand where the 3303 came from. That's my purpose. Do you necessarily have to write that added piece there? No, you can go straight to 3303. I'm fine with that. That would be your fractional answer unless it happens to reduce, which I don't know. I would go for, at this point, the decimal. So homework tonight was some decimal in 3 places. Sometimes it was decimal in 2 places. My answer key, I have it in 2 places. I have decimal to 2 places right now. What are you getting? 0.59 is 2 decimal places.
Oh.
Type something wrong?
Yeah, the 9 didn't go in there.
Okay. Okay, questions on that one? Okay, let's try B. B, it doesn't look like conditional probability. It's just probability. Probability of a female. So if we're going to do probability of a female, and they don't give us any condition there, how are we setting this up? Yeah, we're going to have females over all students. Okay, it doesn't give us a condition, so we're just going to take all females over all students. What do you get for all females? 9,933, he says. What about all students?
11,000.
Disagree.
7,472.
Double check what you typed into your calculator. I have written in my notes the 17,472 number, so sorry, I'm going to decline and go with them. And I will say, there's something to be said, and we're all guilty, myself included. Do watch what you type into the calculator, right? It is so easy to miss, like you hit a number, but it not actually go in. So, okay, let's go decimal to 2 decimal places again.
0.57.
What'd you say?
0.57.
Yep. .57. Okay. What is the probability of a 4-year student, in other words, a student attending a 4-year college, given the student is a male?
Wait, what? The 4-year and male? What would it be?
Depends where you're talking about here. So on top, what kind of number are we looking at, or not? What category are we looking at top?
4-year.
4-year males. Okay. So specifically, because it's, what is the probability the student is a 4-year student given that the student is a male? So on top, we're going to be specifically looking at 4-year males. Over, what's going to go on bottom? All males. Because the condition is that the student was a male. So we're only looking at males. Does that help?
Yeah, that makes more sense now.
And the best way for me to explain this is we've just got to look at examples here. So, how many 4-year males are on top? 4,324. How many males are on bottom?
7,536.
7,539?
I have 6.
I have 9, and I heard 9 back there, so.
I probably just typed something wrong.
And again, we're not leaving these as fractions because these are ugly as fractions because they're big numbers and everything. So, what are decimals here? 0.57 again?
Yep.
Okay. Questions on that section? Did we kind of get a feel for it? Let's go to the next section. Example 2. Conditional probability and statistics. Americans recycle increasing amounts through municipal waste collection. The table shows the collection data for 2007. So, we have it broken down into materials: paper, metal, glass, plastic, and other. And we have recycled versus not recycled. Now, let's look at A. What is the probability that a sample of recycled waste is paper? What are they asking us here?
Put the recycled paper over all of it.
So the question is about recycled paper, yes. So we are going to have recycled paper on top. Because this question specifically says, what's probably the sample of recycled waste is paper. So recycled paper on top, what goes on bottom?
All the recycled.
The recycled waste, yes? All recycled. So in terms of conditional probability, this is, the way they're asking us is, what is the probability that an item is recycled paper, or what is the probability that of paper given that it was a recycled item? So if I was writing this as conditional, I would say probability of paper given it was recycled. So that would be how the conditional would be written in that situation. Probability of paper given that it was recycled. Okay. You question why I asked you to get calculators, right? Lots of good calculator stuff. So what are you putting on top? Okay. 45.2. What are you putting on bottom? 79.4, because that is everything that is recycled when you add it all together. We'll just keep going with decimals. I'm trying to remember. I did the homework this morning again, but I can't remember. It was still a lot of decimals. It was more 2 places than 3.
Only one. It usually said put 3, but you only need to put 2, and then there was one that was fraction.
Okay.
Oh my goodness.
What are we getting here on this one? 0.57. Yeah. Again, watch. If they say 2 decimal places or hundreds, hundreds is 2 decimal places, right? If they say 3 decimal places or thousands, that is 3. And yes, there have been a lot of 0.57s. we'll change that up on the next problem.
Oh, fantastic.
What is the probability that a sample of recycled waste is plastic? So what am I doing here?
Same thing as plastic.
Okay. Probability of the item being plastic given it was a recycled item. So on top is going to be my recycled plastic over everything that was recycled. Well, one of those numbers is easy. What do we know here?
79.4.
Yeah, again, it's out of everything recycled. So again, it's out of 79.4. What about recycled plastic? 2.1. 2.1 divided by 79.4 is 0.03. I have written down 0.0264, but in terms of 2 decimal places, that is 0.03. Okay, one last one here. Probability that a sample of recycled waste is glass. What am I doing?
Glass over recycled.
Okay. Recycled glass over recycled. We will ignore the fact that I just spelled recycled wrong.
It's okay.
So this is probability that an item is glass given it was recycled. Recycled glass is how much? 3.2. All recycled items are 79.4. Hey, turned out to be easy when you get to repeat the same number. 3.2 divided by 79.4. 0.04. So I have written down my notes 0.0403 is what it starts off as. But.
What is one?
Okay. Ready for the next section?
Not reality anymore.
Now, it mentions on the back side, you can use a formula for conditional probability. Now, in all reality, this is what we're already doing. Okay? They're presenting it here as a formula option. The probability of P given A is the probability of A and B on top over the probability of A. So, as we look at this in an example situation, okay, I'm going to use their formula. However, we're going to find out real quick that you wouldn't necessarily have to use that formula. So I want you to be aware of that. A utility company asked 50 of its customers whether they pay their bills online or by mail. What is the probability that a customer pays the bill online given the customer is male? I'm not sure what male really has to do with it here, but obviously that's how they have it broken down. So what is this problem asking us? The probability that they pay the bill online given that the customer is male. Okay? That's what they're asking us. Now, if you want to technically look at the idea of a formula here, well, then that means we're looking at, on top, the probability of A and B. So it's a probability of online and mail, divided by the probability of A, which is just going to be the probability of mail. Isn't that kind of what we were already doing? It is. Now, officially, though, they say to use these P's are indicating we're going to use the probability of each of those. Again, it's going to work out just the same, but I want to show it to you. So, as we set this up, what is the probability that a customer pays online and is mailed? $12 out of how many?
Oh, or do they all have to be mailed, or is it?
Okay, so what we're doing on top is just the probability that a customer pays online and is mailed.
Okay, so for the ones that we did, like the last one we did where it was like both of them, how do you know when you don't do them?
Okay, hold on. Let me do this problem, and then let me come back to your question. Okay? So, probability of online and mail is going to be, just don't even think about today, just think in general. Probability that you pay online and your mail is 12 out of how many? And that's going to be 12 out of 50. So I'm going to put 12 out of 50 on top. Divided by probability that the person is male. How many males do we have here? 20 out of how many? 50. Now, just follow me for a moment, okay? How do we divide fractions by fractions?
You get rid of it.
How do I divide fractions? I don't know that I've heard it yet. If I have, I couldn't hear it.
Oh, you multiply.
Keep change flip, multiply by the reciprocal. Yes? So 12 50ths divided by 20 50ths is really saying 12 50ths times, what's the reciprocal? 50 20ths. And yes, the whole point is the 50s cancel, and you end up with 12 out of 20. Which of course is then going to reduce. 12 and 20 both divide by 4. And I have 3/5. I'm trying to think, did you have any fraction answers today? I don't remember. 3/5 as a decimal is 0.6. Now, they suggested that we can use this formula for conditional probability. Let me back up for a moment. What if we didn't talk probability here? Could we do this the same way we were doing the front side? Probability that the person pays online given they are male. How many was that? That's 12, right? There's 12 online that pay online they're male. Given the person is a male, so how many males did we have? 20. Isn't that the same thing we ended up with over here? Yes. Okay. So that's what I'm trying to show the connection here is that, they say you can use this formula using the probabilities. And so the point is, yes, we're basically dividing probabilities. However, do you have to think this way? No. You could go back to what we were doing on the front side. Probability the person pays online given they are male. So that's the same idea of on top it has to be online males divided by all males. Okay? So it's the same idea and it works out the same. Now, in the process, did I answer your question,
That was
Jocelyn?
exactly my question. I was just following what we did
Okay.
last time. I was confused.
Okay, and that's why I said, hold on,
Yeah.
I need to show it and then
understand now.
connect in the end. Lorna, I got your question somewhere. I didn't even catch what your question was going to be, but you're good? Okay. We're better?
Yep.
Okay. Again, I'm just trying to make the connection. Some of you didn't like it, but you can see it in the end, I hope. Okay, let's look at this one. Researchers asked shampoo users whether they apply shampoo directly to the head or indirectly. I can't read the problem, sorry. Okay, process the question.
Whoever does that is a psycho.
They just take their hand, they're like, smack.
Okay. Researchers ask shampoo users whether they apply shampoo directly to the head, squeeze the ball on your head, I guess, or indirectly using a hand. Squeeze it on your hand, then put it on your head. Whatever. What is the probability that a respondent applies shampoo directly to the head, given that the respondent is female?
They apply the shampoo directly in your hair.
Okay.
No. Hands for that, and then.
Okay. Sorry. I'd forgotten how much discussion this problem brings about
Too much.
how we shampoo our hair.
Waste of shampoo though. 'Cause you
Okay.
don't know how much-
Quick time out. I'm going to push the pause button on the conversation about how everyone shampoos their hair. You can come back to that in the end. Let's do this problem first, okay? So, now, we are being asked the probability that a respondent applies shampoo directly onto their head, given that the respondent is female. That's the question we're being asked, correct? Okay. In terms of setting that up, if we think about that formula that you guys didn't much care for, but I'm still going to think about it, that means on top, we're going to be looking at the probability of, what did I just write there? Oof. Directly, I'm just going to say directly, you guys know what it means, and female over the probability of what? Female. What is the probability that they apply directly and they're a female? 6 out of what officially?
8.
No.
6 out of 30.
How many? They didn't tell us. Are there 50 respondents this time?
There's 30 females and 20 males.
Okay. Again, it's out of a total of 50 respondents. So directly and female is 6 out of all 50 people. What's the probability the person's a female?
6 out of 50.
No. Female is going to be 6 plus 24,
30.
so 30 over 50. Now, basically what happens, the 50s end up canceling, and you end up with 6 over 30. Divide both by 6, and you end up with 1/5, which is 0.2. Okay? Again, could you have just looked at directly onto their head and female out of all females and said 6 out of 30? Yes. And I am perfectly fine with you guys doing that. I'm just trying to introduce the connection here. Yes.
Test time can we do either still?
Correct. Yes, that is, to be honest, I don't have review worksheet and test ready to go because I have a little bit more work to do on this to adjust it to what I need it to be for this year. But that is fully my plan. Yes.
So, like, would next week be, like, the test, and then the week after that would be, like, review worksheet for finals?
Yes. Yes. So, my plan, okay, multiple plans here. Please listen. First of all, I have one more important example in notes to do. So, tomorrow's Friday. I'm going to make this nice. Tomorrow we're going to come in. We're going to do that one last example because I need more than just a couple minutes to explain it. And then, after I do that one last example, you're going to have time to do your homework. Your homework is 7 or 8 questions. So, you should have a decent amount of time to work tomorrow. Next week, I'm going to maybe teach, we have 2 more lessons. May or may not teach those next 2 lessons. We will be reviewing for a chapter test. That chapter test will either be end of next week or very beginning of the following week. And then the following week, and then that week would be final exam review. Leading up to final exams on Monday and Tuesday of the following week. Seniors, I still have to figure out where I'm going with you.
Are there any seniors in
I don't know. Are there any seniors in this class? Are you considered a senior?
Yeah.
Are you considered a senior, Paula? Are you going on a senior trip?
Yeah.
Then you're gonna have to final exam with seniors.
She said,
So-
you got it.
Okay. So I'll get with you guys then.